So CO2 and methane combined are 75% of the problem. They're the two things we need to focus on. And because the methane doesn't last long, that 25% of warming we're experiencing right now, if you cut those emissions from methane, you would see that 25% of warming gone in 2 decades from now.
Welcome to Climate Curious,
We're coming to you live from TED Countdown,
which is TED's Climate Summit.
Now, we all know that TED is normally about sparking curiosity, ideas, even inspiration. But sometimes an issue requires more than that, and climate change is just that issue. So TED Countdown is all about impact, it's all about action.
Right, and we've had an amazing opportunity to speak with some of the world leaders in the climate movement. So this season of the podcast is going to be intense and it's going to be amazing.
There are going to be some moments of silence,
Right.
some moments of awe, definitely some laughter, and some unexpected climate confessions.
Some things that you've definitely never heard before. It's a good season. It's a good season.
So let's get started. Today we're going to have, I think, a conversation that I wouldn't have even known that we should be having
Ooh,
a few years ago.
That sounds mysterious.
I mean, it's mysterious in not a... I mean, I think it's a good way we're talking about it now. But anyway, everyone's going to find out why. But let's get into it.
Today we're joined by Alyssa Aka.
From the Environmental Defence Fund. And tell us what you do, actually, before we get into it.
I'm a climate scientist. I basically study the causes, impacts, and solutions of climate change.
How long have you been doing that?
Let's see. I got a PhD in 2013. And so all throughout my PhD, I was doing research on it. So that was, I don't know, maybe 5 years. And then now for the past 8 years. So I don't know, pretty much a decade, I feel like I've been studying this.
Can I ask a question? Because I always feel like scientists are not a real thing. Do you know what I mean? You don't know what I mean.
I don't know.
I mean, like, when I think of scientists, this is weird, but my mind goes to like Dexter's Lab. And I know that is not real life. It's obviously a cartoon for children. But what is like a day in the life of a scientist? What does that look like for you?
Yeah, I mean, it's a great question. There's different types of scientists and there's days could look very different. So maybe 2 ways to look at it is there are scientists that are kind of in the lab. So they have a lab that they, come to where they run experiments and analyze data. And then there are scientists who go out in the field and are doing something there, which could be interacting with different animals, for example, or measuring water or air quality. And that's how the data is collected and then analyzed. But basically, as a scientist, you have a problem that you are trying to figure out what it is. And you have a hypothesis of, what you think the answer is to the problem, but then you design a set of experiments to test that hypothesis and to see whether or not you're right or wrong.
So are you a lab scientist or a field scientist?
I am a lab scientist, but my lab is a computer because I'm a computer modeler. So I do a lot of climate modeling, which is basically a bunch of math equations all in a computer, and you basically create this virtual world, almost like a video game. Like
So
the
you're
world is a video game, and then I play with different features, and then I, run it for years and years and years, and I see what happens.
So you're like Neo in the Matrix. You're the Neo of scientists.
If you think about the Matrix and all of the code
numbers
on the walls and things like that, I mean, that is the coding that goes into these models. That is what the back end looks like.
I wouldn't have known that from climate scientists. So I'm glad that we got
Yeah,
there.
because
That
I
was
guess it's
important.
like understanding the world in which you work.
Right.
And so I mentioned earlier that we're going to talk about something that I didn't even know we were going to talk about. So I think people listening will know that we've banged on about greenhouse gas emissions now for 2 seasons.
Yeah.
And most people talk about carbon.
Yeah, carbon dioxide.
Yeah. But we're not here to talk about carbon dioxide. We're here to talk about another one. And so I want you to introduce our villain for this episode.
The super villain.
So we are here to talk about methane, which also is carbon-based, but it is not carbon dioxide. So many times people just use the term carbon for carbon dioxide, and it's like, no, you're talking about carbon dioxide. And that's a very specific type of molecule that we care a lot about because we emit so much of it, and it lasts for so long in the atmosphere. So around 40% of the CO2 that we emitted in World War I is still in the atmosphere warming the climate right now. Right? So that's why we focus so much on CO2, because the more we emit it, we're just committing ourselves to warming for generations to come, and that's a problem. Methane is very different. Methane is another greenhouse gas, so it traps Earth's heat, prevents it from getting to space, but it doesn't build up over time in the atmosphere in the same way. It only lasts for around a decade. And so what that means, on one hand, that means that, it packs a really powerful punch quickly. It's not this slow, gradual buildup over time like CO2, but it also means there's a really strong opportunity to reduce warming if you target methane. And so if I could just quickly give an example of how important methane is and why it needs to be a part of the conversation, is because when you look at where our warming today is coming from, only half of it is coming from CO2. That's still a lot, and that's the largest. That's the number one contributor. Methane accounts for more than a quarter of the warming we're experiencing right now. Then once you get past CO2 and methane, so the next contributors, way lower. Around 5% for all the different ones.
Oh.
So CO2 and methane combined are 75% of the problem. They're the two things we need to focus on. And because the methane doesn't last long, that 25% of warming we're experiencing right now, if you cut those emissions from methane, you would see that 25% of warming gone in 2 decades from now.
Which is super important, right? Because if this is the decade where we have to act, being able to see the results quickly is actually key.
We want to see results quickly, and we will not see results as quickly as we would like if we only focus on CO2. And so it's this idea that you need to do both.
Okay. So methane.
Methane is...
Where does it come from? What is it?
I thought that... Am I allowed to say farts? I said it already, haven't I? But I thought methane was like beans and stuff, like farts, not beans, but...
So cows.
Yeah,
we were
cow
talking about
farts.
earlier.
Yeah, so misconception, methane is from burping.
Right. Okay, good to know.
A lot of people think it's farts, and it's not human farts or burping. It's because certain animals have a special stomach, and they're able to break down certain types of food, and they have different microbes in there that break down the food, and it works differently than our bodies, and which is why we don't go around munching on grass, for example.
Right.
Our bodies are not designed
I
to
just
make
thought that was because it wasn't delicious. I didn't realize that.
To us for a reason.
I feel like there's a lot of not delicious vegetables that we still eat. So.
Like aubergines.
But it's not just from
It's
cows.
not just from cows burping. So when we look at, there are basically 3 main sources where methane is coming from. So the number one is agriculture, which is mostly livestock, and within livestock, mostly burping, but also manure.
Yep.
And then the other part of the methane from agriculture is rice production.
Oh, wow.
So basically, just to back up for a second, methane is formed when organic material is broken down, it's decomposed, but in the absence of oxygen. So wherever you have some sort of system where you have bacteria that are breaking something down, but there's no oxygen, it turns into methane.
Right.
And it doesn't get converted to CO2, which is sort of the end product of the chain. So for manure, for example, and for rice production, you end up in situations where you have bacteria decomposing organic material without oxygen, and so you get methane emissions. And so rice paddies are in flooded fields, and the water prevents the oxygen from the atmosphere mixing.
Right, so methane is like space gas. Obviously, that's a really bad way of describing it, but because there's no oxygen in space, right? So it's like anything that is happening absent of oxygen creates any decomposition in that space.
Yeah, that's an interesting way to think about it, for sure.
Yeah, sorry. I'm going to continue to do that the whole time.
Way, so I can't continue that train of thought, but that's sure.
And but you said there were three main...
I said there were three.
And you
So
said two.
agriculture is the number one, which is around 40%
Right.
of emissions. The second category is energy production,
Okay.
which is also around 40%, but just slightly less than agriculture. And so energy production, it's not burning of fossil fuels, it's producing the fossil fuels. So for example, very similar with this lack of oxygen, fossil fuels get buried underground, lots of pressure, like it packs up over time, and it creates these pools of gases or oil or coal, and all of those things have natural gas sort of mixed in, and natural gas is almost entirely methane. And it's formed because of the same things of breaking things down over time, and you don't have enough oxygen down there, and so it just turns into this gas that's mostly methane. So whenever we extract oil, gas, or coal, we leak methane into the atmosphere. Whenever we transport gas, we leak methane into the atmosphere. At home, when we're cooking and heating, we are leaking methane into the atmosphere.
Right.
So that is, oil and gas is most of the energy emissions of methane. And then coal mining is the remainder. And so that's the energy component. And then there's a third category, which is waste management. And that collectively is around 20%. The majority is from landfills. Same thing. We bury all this trash. It's food, it's yard waste, no oxygen anymore. So the bacteria break it down, and then it just forms methane. And so the methane escapes. And the same thing with wastewater. You just don't have enough oxygen mixed in the water. So it all comes down to the very same kind of chemistry.
Space gas, diamonds, and trash.
I mean, I don't know where this is coming from, but I can follow your train of thought. I like it. I actually want to ask about that third category for a second, and then come back to the other one. I had never really understood why we had to separate, for example, food waste from other waste that isn't recycling. And is this the reason? Because of decomposition?
It's because it's an organic material, just like we are, when we die. It's very different than plastics, for example, or textiles. When you throw those things out, those things are problematic too, but usually on the front end, because producing the plastics uses a lot of oil. And it's a different environmental challenge on the landfill end of breaking down plastic or whatnot, and it can be dangerous for wildlife and whatnot. But in terms of the methane emissions, it's really the organic materials like the food and yard waste, like yard clippings.
Like when you mow your lawn, basically.
Yeah. And then,
that stuff.
You fill those bins, and you rake your leaves, you fill, your paper bag with it, someone comes and collects it. If that gets buried in a landfill, I mean, you're going to get methane.
So two questions. One, the solution to this obviously is not to not cut your grass. The solution is to not bury stuff underground.
That would certainly help. One of the many solutions is, could be using composting centers instead of landfills. So yes, take as much as food waste and yard waste as you can, send it to these composting centers that mix in the oxygen. They make sure that the food gets broken down in the right way so that it only releases CO2. Okay. And yes, CO2 is a greenhouse gas too, right? But the thing here is that it is part of the carbon cycle when these foods grow and they use photosynthesis and they take in CO2 and then they break down, they release CO2. That is a more natural cycle. And the methane being produced in the middle there,
That's a man-made thing.
We have created this middle step where now all of a sudden it's methane for a dozen years. And that methane packs a lot more warming than the CO2, because for equal mass, the methane can warm more than 100 times more than the CO2 can for equal mass.
So when you said in the beginning, you said it's 25% and we can get rid of it. Is that possible? Like, can we actually completely erase all of the methane production?
We have the technologies available right now to cut emissions of methane from human activities in half.
Wow.
That is a lot.
Yeah.
We can't do it all, nor do we really need to do it all because it doesn't build up over time like CO2, right? So there is an amount that if we can't get to it, we don't need a net zero methane.
Okay.
You know, we as close to zero as we can possibly get with our technologies will help, you know, lower temperatures, and that will help with what we can't do with carbon dioxide, for example. So it's in our best benefit to reduce methane as much as possible.
Because 12.5 is still a lot of 100%, right? Like that's still a big chunk of.
Oh yeah.
That's huge, actually.
Yeah, and it's so basically we did calculations to see, and we have a paper that we published a few months ago, me and my scientist colleagues, that shows if we do a rapid, full-scale effort to cut these methane emissions in half over the next 10 years, we could slow down the rate of warming by 30%.
Wow.
And that's a really big deal. I mean, that is a lot of damages that you would be avoiding.
Right.
You know, a lot of extreme weather events. The latest IPCC report showed that every increment of warming matters and makes these events worse and worse.
Yeah.
So if we can shave off some of that warming, I mean, we're saving so many lives.
Right. And I think that's an important piece there, right? Because we don't often think of, or I don't often think of events in terms of lives, in terms of people. But that's a huge amount of 30% reduction.
Yeah, like extreme weather just sounds like it's extreme.
Like bad rain.
We're actually talking about people's homes being destroyed, people dying.
Oh my gosh, it's horrifying what happened the last 2 years with extreme events. I mean, temperatures recorded in Canada that have never been recorded on record. I mean, people died because you get heat strokes. Your body can't adjust to that level of heat. And it's scary.
Right, so Mariam, I've been thinking, how did we start this podcast?
That's a great question. So at TEDx London, we're all about ideas worth spreading. We've explored everything from gender and borders to technology and design at our events. We've been doing this for 5 years. And in that journey, City has been our headline partner, and they've been with us every step of the way. But when it came to the climate crisis, we needed a new format. We wanted to break out of the red circle, to speak directly to the climate leaders, to ask questions and to be curious. And as always, City was there with us, supporting our vision, encouraging us to be courageous and adventurous with our ideas. So thank you, City, for making this podcast and all of our work possible. For the love of ideas, for the love of curiosity, for the love of progress. City. Now back to the show. When we think about the savings that you're talking about here, I have started to see, especially while we've been here at TED Countdown, one of the pieces that's really coming together for me is this idea of when you look at it holistically, you know, the idea is net zero by 2050, you know, and then most people agree that that's 50% by 2030 to hit this 1.5 degrees, which avoids the worst, well, not the worst would have been getting to zero, but we're past that, right? And what I'm trying to realize, my point here, very belatedly, is that it's all about seeing what can you do now to buy you time to do the things that are harder to do later. Right. And if I'm understanding you correctly, this 50% of methane that we can address now buys us time for the things that are harder to do.
So I tend to stay away from the term buying time only because sometimes you're not wrong whatsoever, but sometimes people interpret that as we can delay.
Yes, I guess it's
you know
not,
what I mean?
Yeah.
So it's like, oh, well, that gives us more time to figure out things or whatnot. Really, what we need to do is act as soon as we can on what we know we can do for both CO2 and methane. But what methane does, in a sense, give you more flexibility with, I'll say, is that there are some really difficult things we need to do with CO2. We really need to scale up removal mechanisms, for example. And if we don't do anything about methane, we're making the challenge harder for ourselves.
Right.
And we're going to have more warming in the near term than we otherwise would. So what the methane can do is give us that safety we need in the near term while those strategies are still being developed, so that we can really prevent a lot of catastrophic damages over the next 20, 30 years while those things are being developed.
So the impact will be more immediate with...
Yes.
Yeah, right.
Yes.
So I want to come back to that second 40% that you talked about, which was the production of fossil fuels.
Yes.
And the leaking.
Yes.
And ask you to tell us a little bit about your satellite.
How did you know about the satellite?
I find the satellite very, very cool, and I've been waiting to ask about it the whole time.
Awesome.
So I want to know about the satellite.
Tell us about the satellite.
So it's so interesting with these methane leaks because it's really easy to fix these leaks. The problem is, where are the leaks coming from? It's, they're invisible. We don't know. I mean, there's some really, clear suspects, but overall, I mean, we're talking about big supply chains, kilometers of pipeline. So, where are these leaks coming from? And so we've been developing a lot of technologies over the past decades to be able to do this. And one new technology that we are so excited about that I actually got to see about a month ago, parts of it's being designed in Colorado, is this satellite called MethaneSat. And it's expected to be launch ready next year. And what MethaneSat can do is locate these leaks across the entire globe with unprecedented precision. Oh. So our ability to really know where the leaks are coming from and how much is being leaked is just, it will tell us like who's responsible for the leaks. It will tell us what the full picture is to get a sense of how much is actually coming globally from this industry. It will help us know where to target our efforts to fix these leaks, which again can be super simple, like on the level of plumbing versus rocket science, but we just need the information on where the leaks are. And so this satellite will just, catapult us towards that knowledge. And, we're going to make this data publicly available. We want it to be as transparent as possible so everyone can be held accountable and we know what's going on.
So out of 100% of methane that's in the atmosphere at the moment, 40% is coming from leaks.
So we need to take a step back because there are natural emissions of methane. Okay. So around 40% of methane that is emitted into the atmosphere now is from natural sources like wetlands. Okay. 60% of the methane that's being emitted and that's in the atmosphere is from human sources. Of those human sources, 40% is coming from the energy sector.
Okay. And so where you said that you have a good idea of where it may be coming from. I don't know if this is like moving into like incriminated space or if you mean like in general, they're coming from pipes in a certain region.
Yeah.
Or...
I mean, over the past decade, we've just learned so much from studying systems in the U.S. to get a sense of, there's a lot of leakage at the wellheads or flaring equipment that isn't working properly, where the flare is, so things like that. Big facilities, certain basins tend to be, we've located more emissions coming from, for example, the Texas area and the operations happening there versus the Pennsylvania area that tend to have less emissions. So it's, and we've also seen in other countries too, like Mexico City, a lot of emissions, very leaky, but in the Netherlands, pretty good systems, doesn't leak a lot. So sometimes there are certain types of infrastructure, like the, from the upstream emissions, you kind of know what equipment to look for. For the midstream, you kind of know, the pipelines, and then in the end product, the end use, it's really hard to gather, data for that, but it's, very likely that all these pipes going into everyone's homes that are kind of underground are very leaky. And we've been trying to refine data on that. So you kind of could have like your sense of this area tends to leak more or this type of equipment tends to leak more. But you really, having a satellite or having drones that really can fly over and pinpoint it. I mean, a really good piece of news here is that a study by my colleague a few years ago showed that it's a small minority of sites that are really responsible for the majority of emissions. And so that really helps solve the problem, because you can just target those specific facilities and make a big dent in the problem rather than going to every single oil and gas facility worldwide. But right now, we don't have eyes on the whole world.
Well,
so
this is what one of the speakers today was talking about, and I hear from you a very similar thing. This idea that when it comes to the energy sector, when it comes to oil and gas specifically, and coal, we have no visibility. There's almost no transparency now on so many different levels. This speaker was talking about accounting. You're talking about these leaks, and what the satellite allows you to do is bring that transparency out into the public, which means that you actually have the information you need to act on it.
Yeah, it's any good decision requires good information. And I am a scientist, but the whole goal of my science is to be science to action. It is to provide a decision maker with the best available information so they can make the most informed decision possible. And so many times I just see that the data we have, the information we have, the analytics we're using, it's just not good enough, and it needs to be better so that we make good decisions and maximize our climate benefits going forward from any climate action effort we undertake.
So let's say they haven't finished building the satellite. Mm-hmm. They haven't.
No, it's coming next year, you said, right?
It should be launch ready. Yeah, end of next year.
So it goes to space or the atmosphere and it's floating around.
Yeah.
You are able to identify where the leaks are coming from, and then what happens?
So the way the instrument works is it's basically trying to detect light, and it knows how much light it should be seeing.
Right.
And then if it's not seeing that amount of light, it's because methane is there.
Okay.
And you could do that because methane absorbs a very particular wavelength of energy. So you're looking specifically for that wavelength. And so that's how you can kind of get a sense of, oh, there's methane down there.
Yeah.
And then because of the precision of this instrument and the small scale that it's able to look at, you can get an idea of the area that it's in. Within that area, you overlay that with a global inventory of oil and gas facilities, and now you know which companies are around there. So not only do you make this data available publicly, but you act on it. You go to the responsible authorities and you make them aware of this problem, and maybe you tell them how to fix it, or maybe they already know that, but now they're, in a lot of cases, now they're aware of something that's where they're losing product, and there are so many different opportunities to resolve that issue, so they can go in and immediately fix it. They may have just not been aware of that at all. It's not necessarily that they're trying to pollute the environment. They just maybe didn't know. They didn't have the data. So now they do. And if they don't want to act, well, now the data's public. So now everybody knows that, look what you're doing. And so there's that public pressure too of like, hey, we see what's happening. You need to do something about it.
Okay, I like that.
Yes.
So not everyone's villains, like not everyone, because I always think of everything in terms of like heroes and villains, and I need to stop doing it because I know that the issues are much more complex than that.
Yeah,
sometimes
characters.
there are anti-heroes.
Yeah, I was introduced to that concept years ago when someone said, I don't like being engaged with the climate change problem because I always feel attacked, like I'm evil.
Right.
Like if I'm not a climate activist or even a Democrat, like I'm evil. And it's just, this is human advancement. We, used to rely on burning wood for fuel, and then we found something that's way better and energy intensive, and that was coal. And then we found something that's better, and that was oil. And then we found something that's even better, that's natural gas. And now we're working on solar and wind. This is just human advancement over time. And over time, you learn that some things that have problems or weren't working for the best, or there's a better alternative. And this is just that process. There are some bad apples, but we need to be careful.
Yeah, because if you paint everyone as a villain, then the actual people who are acting in bad faith,
it'll just push them away. You know.
So I think what I like about this is we've talked a little bit about the systems piece that you're looking at, like the big societal changes, the shifts that need to happen. And I think for us, we always like to think about this as not it's not about just system change or just individual action. It's all of it. So for people listening who are thinking, okay, so now I know about methane. Now I know where it comes from. I understand it. I know it's bad. I know that some of the actors who have to act to make the big changes, but is there anything that I can do?
Yeah. So
if you're not a satellite, what
Yeah.
what can you do?
If you're an oil CEO or a natural gas CEO.
yeah. So if you're not a company or a government,
Or a cow.
or a cow. I mean, I think about this a lot. I think about my daily activities and what involves methane. So if we want to reduce our impact, I mean, I don't want people to think that they can't live the lives that they want to lead, and so we're constantly trying to think of upstream changes that, and not have to rely on the individual. But if you want to do something as an individual, start composting your food waste. So make sure, or look into, some cities have composting centers, have programs where they'll have different trucks that come pick up your food waste and your yard waste and bring it to a composting center. For your natural gas use in your home, for either cooking or heating, I mean, having solar panels on your house, if you can.
That sounds manageable.
That sounds doable. We can all do that to different degrees. And since you mentioned this idea of like, oh, it's so hard, I think it's time we move to our final segment.
Oh, yeah.
Right, Ben?
And now it's time for our climate confessions. Let's fess up to the bad habits we just can't kick.
So I think everyone knows what climate confessions are.
I feel like
if you don't know, go back to previous episodes, watch it. You'll know. Right. Right?
Yeah.
It also felt self-explanatory to me when you
climate
first mentioned it. Like, I wonder if this is.
Yeah, we want to know what it is. Well, I think you said that when we first told you about it, you knew immediately.
Yeah.
So I want to jump in.
I've already said it. I mean, I take baths. That is.
That's the one.
That is the one, and that's a problem for methane and carbon dioxide. I, even had an intern do all the math for me on like how bad my bath actually is.
This is gonna be. We have to take a minute because we're in the UK. This is gonna be devastating for people.
Yeah, this is
people
brutal.
take baths here.
Baths are
I
don't.
Yeah,
I don't like
it's a
baths,
national pastime.
but it's a national pastime here.
Yeah,
so we're gonna have to break that down a little bit.
It's an Alyssa pastime as well, and it's funny hearing that, and it makes me happy because I actually know very few people at home who take baths. So they're like, "You take baths?"
No,
that must make you feel so bad.
I love baths. That is one of the only ways for me to decompress at the end of the day. And it's like part of my de-stressing routine.
Facts.
But here, I feel like I spend my days trying to solve climate change, right? Like I am trying so hard to address this challenge. And it's like, I don't want to, there's so much that needs to be done. And I'm only human. And I also need to be mentally healthy to be able to be in the right mindset to do the work that I need to do, and also raise a toddler who is a terrible toddler, by the way, and is like a monster right now. So it's like, I need the baths. It's important to me. But, I can't be perfect, and I'm not going to cut out all the, enjoyments of my life. What I'm trying to do is work from these high government company levels so that that systematic change that needs to happen can happen, and it doesn't fall on the burden of the individual who has to feel guilty all the time.
And I think that's the point of this segment as well, is that guilt doesn't get us anywhere. And actually, if we can make smart decisions and ask smart questions and be thoughtful, we can all take a bath every now and again, or as we discovered earlier today, you can have a burger.
I can
if
still
you need to
eat
have one.
a beef burger.
But it's all about looking at it on a different scale. So we just want to say thank you for sharing that with us and being here. And now we all know what we need to know about methane. So this has been wonderful.
Well,
Amazing.
Thanks for bringing attention to this important issue that just seems to get overlooked.
Thank you for bringing attention to this important issue. We just listened to you tell us about it.
You invited me to be here. You gave me the platform, and I'm honored.
Thank you so much for joining us this week. We really hope you enjoyed this episode.
If you did, please rate, subscribe, and share this episode with a curious friend. It makes it possible to keep making this amazing content for you.
Oh, and slide into our DMs at TEDx London and let us know which climate extraordinaires you'd love to hear from next time. Oh, and don't leave yet. We wanted to tell you a bit more about who made this podcast possible.
Yeah, we did. TEDx London's headline partner, City, has been supporting us for the past 5 years to bring world-changing ideas to the TEDx London stage. And now they're taking it to the next level by making this podcast possible. Thanks, City.
But wait, that is not all.
No, this podcast was produced by the amazing Josie Coulter.
Curation and research by the genius Tara Cooper.
Artwork designed by the visionaries that are Sabrina Russo and Rebecca Mingus.
Mixed and engineered by the iconic Ben Beheshti, aka The Falcon, who also composed our banging theme tune.
Presented by me, Mariam Pasha.
And by me, Ben Hurst. Stay curious.